So now in this video, we want to get 100 milliamps of current basically going through resistors or a resistor from 4 volts right there. To do so, we would need a 40 ohm resistor though, and most resistors are quarter watt resistors. That would be too much wattage for one resistor to handle. So we have a couple options if you only have a quarter watt resistors, and this is just approximately 100 milliamps, but we could put 4 of them in parallel, relatively high value resistors. That would be perfectly fine. I'm using 4 volts just because the math is easy, but we're going to go over the math. It works the same with pretty much any voltage. Or we could put some low value resistors in series. The main takeaway for this video is that when you got resistors in series, they divide up the voltage. That's based on their percentage of the total resistance, and when they're equal value, that makes it easy. We got 4 equal value resistors here. Each one of them is going to have 1/4 of the total voltage across them. So that's important for calculating the power that it has to dissipate. When it comes to parallel resistors, they divide up the current. So you can see here we got series. The same current has to flow through them. When you have a circuit, a series circuit, everything has the same amount of current flowing through it at all times. Whereas a parallel circuit, the current's going to flow here, and then it's going to flow through each resistor independently based on the voltage across them. So all these 150 ohm resistors are going to have 4 volts across them. They're going to pass current accordingly, each one of them, but we got 4 of them. So when it comes to the total, we're going to have 4 times the current that one of them provides. So now when it comes to how much current is going to flow through a series circuit that just has resistors here, it's going to be the voltage divided by the total resistance. So these resistors, since the current has to go through 4 resistors, you have 4 times the resistance, the total resistance I should say. So we got 4 10 ohm resistors. That is 40 ohms of resistance. So if you have a resistor that is 40 ohms, just one resistor, it's going to let through about 100 milliamps of current through it. That 100 milliamps, 0.1 amps, you do the calculation in amps, times 4 is a 0.4 watts right there. So wattage is the current times the voltage, voltage times current, whichever way you want to look at it. So in any case, these are quarter watt resistors rated for 0.25 watts that we're going to use in this video, and you should still keep them below 0.125 watts. So that's way too hot for one 40 ohm resistor that's a quarter watt. But you could use a 1 watt resistor. That's a little less than half of a watt. You want to keep the power dissipation below half of its rated value. That would be perfectly fine if you got one of those. But like I said before, if you don't have one, you can put 4 in series. So each one of them is going to have 1 volt across them, and because they split up the voltage, they're in series. The voltage is the sum. The voltage across all the components is the sum of what the full voltage is. So they all add up to get to the full voltage. If they're equal value, they got the same voltage across them. But in this case, we still got 100 milliamps right there. And we multiply that by 1 volt across each resistor. Each one's dissipating 100 milliwatts, 0.1 watts of power. And so that is below what each one of them is rated for, 0.125 watts. So now we come to the parallel resistors. And you can see here that as voltage goes up, because these resistors are going to get about as hot as those are right there. So for 4 times the voltage, we need a lot more times the resistance per resistor right there when they are in parallel. And that's because you got more voltage across it. It's voltage times current. Voltage times current down here. But in any case, we have an equivalent, if there's 4 of them, of 37.5 ohms. 150 ohms divided by 4, so I'm going to kind of rush through this. But in any case, if you just have one resistor, or the equivalent, whatever, you're going to end up with about 107 milliamps, 0.107 amps, just a speck below that actually. And so you take that current times 4, you're going to get 0.428 watts. So you're going to need a 1 watt resistor if you're just using one resistor. But now they are sharing the current that they have to pass. So they're passing about 1/4 of the current of a single resistor of lower value up here. And so now we got the 4 volts divided by 150 ohms. You're going to get about 0.027 amps through each resistor. So we're going to have 4 times. But each resistor now is going to have that current times the voltage. It's going to be about 0.108 watts, which is plenty cool. So now we got the total current though. Each one of them is going to pass current independently, so times 4 since they're equal value. And now we're back to having about 108 milliamps, 0.108 amps, which is close to 100 if that's your goal. So now here we are with the FLIR image, and it looks like the parallel resistors are a bit warmer than the other ones, and that's in comparison to my finger. So they are not terribly hot right now. You can see we got a series there. Here is the board. So we got the 150 ohms to the right. At the very top you can see I got a resistor. I spun its legs together because it is actually in the millions of ohms. I don't know, that one's just bad for some reason. So this is a cheap kit, but you get a lot of values, and the leads are a little thin. So that's the first one that I think was horribly bad. But in any case, there you can see we got about 200 and almost 8 milliamps of current, which is what we calculated. If I pop one of these, and they are a bit warm, there you can see we lost about 100 milliamps. And we're working with just a tad bit above 4 volts. And so in any case, we get that back into the right row. Now you can see we got the total current, whereas we lose about 108 almost milliamps right there, approximately. So in any case, there you can see that we had those different current flows there. So in any case, that's it for this video. Hope you enjoyed. Make sure you check out one of the other videos I'm posting. Click like, subscribe, the bell, that, donate to Patreon if you can. That helps out the most. But just watching videos helps out a ton. Thanks to everybody that does that. I will see you in the next video.